Okay, so this video starts us off in Unit 3, where we're going to be talking about functions. So it's important to know the difference between a relation and a function. So a relation is a relationship between an input and an output. So this is kind of a generic definition. Anytime you have an x and a y value, an input and an output, it's considered a relation. And so a function is a special type of relation where each input, so each x value, has only one output. So a relation is the big category and a function is a special type. So we have this diagram to show relation is the big category and a function is a special type within that big category. So if you are a function, you're always going to be a relation because you live inside of a relation. If you are a relation, you only sometimes will be a function because all of the relations out here that don't fit into this special category of function would not be a function. So sometimes a relation is a function, always a function is a relation. That's a great question for a test. So here we have a mapping diagram. Just to remind you, input is the x variable, output is the y variable. And what a mapping diagram shows is it shows us that when 2 is the input, it matches with 20 as the output. But we also see that 2 is matched up with 40. So we would say this relation, this is a relation because we have inputs and outputs, is not a function because 2 has 2 different outputs. So is this a function? No, because 2, so the number 2, has more than one output. Down here, if we look at all the inputs, so the inputs again are the x value. I meant for that to be a highlighter. The x values are 4, 6, -5, and 3. So this is going to be a function because each input only shows up once. So there's no way for the inputs to have a repeated value. So this is a function, yes, because each input has one output. I like to abbreviate this because this explanation shows up a lot. You'll always say the same explanation to say if something's a function. So if something's a function, I like to say this acronym, EIHO, E-I-H-O-O. Each input has one output. And so you can put that as your explanation as to why something's a function if each input has one output. Let's say I added an ordered pair here. Let's say I added 6, 7. Is this still a function? 6 is repeated as an input twice. I have it here and I have it here. So this would no longer be a function if we added the point 6, 7 to that relation. It would only be a relation. So when we look at graphs to determine if they're a function or not, we like to use what is called the vertical line test. So the vertical line test says, if you draw a vertical line and it crosses a graph more than once, it is not a function. So for instance, this first graph, I could draw a bunch of vertical lines through this graph. I could draw one here, I could draw one here, I could draw one here, I could draw one anywhere on this graph, and it's only going to intersect with my graph once. Once here, once here, once here. The vertical lines indicate an input, right? So I drew it through x equals 2, x equals 0, and x equals negative 2. And so since it only crossed once, this is a function because each input has one output. It only crosses the graph once. Same thing here. If I draw a vertical line here, if I draw it here, no matter where I choose to draw my vertical line, I'm only crossing my function or my graph ever once. So again, this shows that it is a function because each input has one output. And so here, this one's a little bit unique because if I draw a vertical line through x equals 2, my graph touches the line twice. And so here is the point 2 comma 2. Here's the point 2 comma negative 2. And so we see that the input 2 has two different outputs. That's not a function. So we would say no, because each input doesn't have one output. So that makes it not a function. And so this is function notation if we ever go to write an equation of a function. So f tells you the name of the function, so the name of this function is f. We sometimes give it different names, so we could say g of x. The name of that function would be g. X tells you what the input is, so sometimes we might say the name is h, and what we're going to put in instead of x, we're going to put in t. Because maybe we're making a function and the h stands for your height, and t stands for the time you've been alive. So we use the variables to represent certain situations. And then 2x, this whole thing here, that's the function. That's what the operation is to get the output. So to get the output, we multiply x by 2, the input by 2. So we can use this notation to help us find values of a function. So here, f of negative 4, that means that negative 4 is my input. That's what's going to go in for x into my function. So wherever I see x, I'm going to put in a negative 4. So we would write f of negative 4 equals 3 times negative 4 squared plus 4. So I just replaced the x with the input negative 4. And then I just do PEMDAS. So negative 4 squared is 16, so it's 3 times 16 plus 4. Which is 48 plus 4. And so we get that f of negative 4 is 52. So when we put in negative 4, we get out 52. We can also put in expressions. So here I have 10n. That's going to go in for k in this function. So where I see k, I'm going to replace it with 10n. So we get g of 10n equals 5 minus 4 times 10n, which is 5 minus 40n. And so our answer, instead of being a number like the last time, is actually an expression. And so we have vocab words to name the set of inputs and the set of outputs. So the domain of a function are the set of input values, or the set of x values. The range is the set of output values of a function. or the set of y values. So for this example, the x values are 0, 3, -3, and 2. So our domain is 0, 3, -3, and 2. The range are the set of y values, 2, 4, -2, 4. So our range is 2, 4, -2. Notice that I only write the 4 once. So from our functions earlier, my x values were 2, 4, and 3. My y values were 20, 30, and 40. So that would be my domain and range. And when we write domain and range, we use this little curly bracket to show that it's the set of numbers. B is a little funky. I just want you to write down B, and we will talk about how to do a problem like D in the future. So the domain for B is that x starts at -3 and goes to +3, and it's all the x values in between. So we write -3 less than or equal to x less than or equal to 3, kind of like an inequality. The range are the y values. Those go from -3 up to +3. So we say -3 less than or equal to y less than or equal to 3, because range is the y value.